Idly ho, students, Mr. Kaczynski with you, and we're going to go through lesson 8.0, or refreshing your skills. It's called in our textbook, and it's about factoring and multiplying. It should get us into working with all these polynomials and quadratics that we're going to be dealing with here in chapter 8. All right, so let's go here on the first set of problems, and the directions are: complete the following tables using as many integer values of x and y as possible. Okay, well, what times what equals 12? I mean, obviously, we could go with 1 times 12 equals 12, and we can go with 2 times 6 equals 12, and we could go with 3 times 4 equals 12. And obviously, by the commutative property of multiplication, you could do this backwards too: 12 times 1, 6 times 2, and 4 times 3. So, is that it? Did we come up with as many as we could? No, there's actually 3 more pairs. There's -1 times -12. Those are both integers, and when you multiply them, they equal 12. And how about -2 times -6? That's also positive 12. And -3 times -4, that would be our last set, right? Okay, so you get the idea here. Important to remember those negatives. Ooh, what about if the product is -12? Well, -1 times positive 12, that'll give us -12. -2 times 6, that'll give us -12, and -3 times 4. So we get those same 3 combinations, but now order kind of does matter. Where you put that negative sign is going to affect this. So 1 times -12 will give us a product of -12, 2 times -6, and lastly, 3 times -4. So I think parts C and D, on number 1 here, just kind of hammer this home. Remember that the factors of a positive product could be positive, 1 times 7, or the factors of a positive product could be negative, -1 times -7. And when we have a negative product, it could be that the first product is negative, like -1 times 7, or it could be that the second, or factor, I said product, the first factor, the second factor is negative, like 1 times -7. 7's a prime number, so a little shorter as opposed to 12, which had all those factor pairs. All right, let's move on to number 2 here. Now the directions say use a rectangle diagram to multiply or factor the following expressions. So right now this expression is in factored form, and what we're going to do is write it in expanded form. We're going to multiply this 4x times this sum of 150x plus 8. So here's my rectangle diagram. I've drawn a rectangle. I've got one of its dimensions being 4x, kind of like up here, and its other dimensions being 150x plus 8. Like the length of this entire line is 150x plus 8. And I've got that divided in parts there. So length times width should equal the area of this rectangle, right? Length times width equals area. And that's what we're going to do, is we're going to figure out the area of this. All right, so let's do 4x times 150x. That is 600x squared, as in 4 times 150 is 600, x times x is x squared. Just like 2 times 2 is 2 squared, or 7 times 7 is 7 squared, or pi times pi is pi squared. X times x is x squared. Now we're going to do 4x times 8 to figure out the area of this rectangle. So 4 times 8 is 32, and then you got that x, 32x. 4 times 8 times x, or 4 times x times 8. All right, so what's our answer here? We're trying to write this in expanded form. The sum of these two areas should be the area of the entire rectangle, and that's why that's our answer. 600x squared plus 32x. You can't go any further than that. Why don't we take a quick second and put this into the calculator here. Put the original expression, 4x times 150x plus 8. And we'll put the new expression, 600x squared plus 32x. And we'll look at the tables, and we'll see that those tables are equivalent, meaning this original expression in factored form is equivalent to this original or this new expression in expanded form. Some people might say, well, I want to simplify this to, I don't know, 632x cubed maybe. But you'll see that those tables are not equivalent, so those expressions aren't equivalent. Let's move on to another one. Okay, this one is in expanded form, and we're going to write it into factored form. So we've got the area of the rectangle. We just need to figure out what are the dimensions of the rectangle. So the area is 24x minus 12x squared. 24x minus 12x squared. So we got to figure out the length and width of this rectangle to be able to write it in expanded form. All right, well, let's think greatest common factor. What's the greatest common factor of 24 and negative 12? 12. They're both divisible by 12, right? And then we might also think, what's the greatest common factor of x and x squared? They're both divisible by x, okay? And we've talked about this in class before, but when you're trying to figure out the least common, or the greatest common factor of like x terms, just take the lower power. You know, you got x to the first and x squared. Their greatest common factor is x. All right, so now we need to figure out the width. Okay, so we're thinking 12x times what gives us 24x, or 24x divided by 12x. You know, fact families should give us this answer. 24 divided by 12 is 2, and x divided by x is 1. So 12x times 2 is 24x. All right, and then over here, 12, maybe negative 12 divided by 12 is negative 1, right? And then x squared divided by x is x, or x times x is x squared. So when we write this in factored form, it's going to be 12x times 2 minus x. Let's do this again on the calculator. So we got our original expression, 24x minus 12x squared. And we've got our new expression written in what we call factored form. 12x times 2 minus x. I go to the table, and those tables are equivalent, telling me that those expressions are equivalent. This will check that your answers are equivalent. It won't necessarily answer that it's all the way factored. You know, some people might say the answer is 12 times 2x minus x squared, because they only factor a 12 out instead of a 12x. Well, those are equivalent expressions, but you can still take that x out of those parentheses there. All right, let's move on. All right, now in 3, we're supposed to be using the distributive property to factor this without doing any rectangle diagrams. So we want to multiply this entire expression, 2 minus x squared, by negative 3. So to do that, using the distributive property, we're multiplying each one of those pieces in the parentheses by negative 3. So it's negative 3 times 2, and then negative 3 times negative x, and then negative 3 times negative x squared. 2, negative x, and negative x squared all need to be multiplied by negative 3. And the result of that is this. Negative 3 times 2 is negative 6. Negative 3 times negative x is positive 3x. You have a negative times a negative. Or you're subtracting a negative, so you're really adding. And then negative 3 times negative x squared is positive 3x squared. And of course, I'm not going to do this every time, but we'll do it a few more times. Negative 3 times 2 minus x squared. And let's put our new expression, which is in expanded form, we call it. There we go. Let's go to the tables. They are the same. Go to the graphs. You're only going to see one parabola because they are the same parabola. All right, again, we want to use the distributive property to write this in expanded form. So all of these 3 items, 2x squared, negative xy, and positive 3y squared, all need to be multiplied by x squared y. Okay, so it's x squared y times 2x squared y times negative xy, and x squared y times 3y squared. This is a lot. It's looking like a lot, but we'll just break it down piece by piece. So we got basically 1 times 2 is 2. X squared times x squared is x to the 4th. Y times, I guess, y to the 0 is just y. So there's our first product. Let's go again. We got x squared times negative x, which is negative x cubed, or maybe a positive times a negative is a negative. X squared times x is x cubed. Y times y is y squared. And our third product, you got 1 times 3, which is 3. X squared times, there's no x over there, so it's just x squared, and y times y squared is y cubed. And that's our new expression. Now I can't put these into the calculator because I've got multiple variables. I mean, there's things I could do on the home screen where I could choose a value of x and a value of y, but that's going to take me too long, and I want to move this along. All right, now we've got an expression written in factored form, and we're going to write it in, I'm sorry, it's in expanded form. We're going to write it in factored form. All right, so I'm looking at this as like both of these are divisible by 2k, right? I mean, 2 and 4, their greatest common factor is 2, and k squared and k, their greatest common factor is k. So this is kind of like distributive property backwards, all right? It's that same middle step I'm showing you, but your job is to break it up. Okay, so what is the thing that each piece was multiplied by? In this case, I think it's 2k. And then we can write it into factored form like this. 2k times k is 2k squared, and 2k times negative 2 is negative 4k. Let's do that one more time. Whew. What are all of these divisible by? We got negative w squared z cubed, we got positive wz squared, and we got negative 3wz. Okay, just take it piece by piece. I see a negative 1, a positive 1, and a negative 3. What are they all divisible by? 1. But when the lead coefficient, when this lead number here is negative, we are going to factor out a, can I do this here? No, let's go like this. We're going to factor out a negative, okay? So negative, positive, negative. They don't have any common factor, 1, 1, and 3 other than 1. So I'm just going to factor out that negative sign. Okay, now w squared, w, and w. They're all divisible by w. You just take the lowest of the 3 powers. Okay, so you got squared, first power, first power. We're going first power. So w, they're all divisible by w. And then z cubed, z squared, and z. You take the lowest of the 3, the 2, the 1. That's the 1. So they're all divisible by z. Negative wz is our greatest common factor of these 3 terms, okay? So let's factor out that negative wz out of all 3 of them, okay? W times w, w squared. Z times z squared, z cubed. You got your w. You got your z times z is z squared. All right. We got our w and our z out of there already. And you still just need that 3, okay? Might take you a few times, but hopefully you can kind of connect the dots here. Also, when you're factoring it, or division, think about it as subtraction. Terms with the same base, when you're dividing, you subtract their exponents, right? So 2 on this w minus this 1 on this w gives us 1. 3 on this z minus this 1 on this z gives us 2. 3 minus 1 is 2. All right, so there's our final answer. We got our greatest common factor on the outside and the result here on the inside. So length times width equals area. And we got one more. We're going to use this idea to solve a very crazy looking equation here. Whatever, we'll use pink. All right. So we got this equaling this. Well, I'm looking up here at the top and like, is this a factorable expression? And I think it is. And also on the numerator, this second fraction, is that factorable? Yes, yes, it is. Okay. I'm thinking that the top expression here, the numerator on the left side, all 3 of those terms are divisible by 2 and they're all divisible by x. So I'm going to factor that 2x out of it. And then over here on the right, they're all divisible by 3. 3, 12, and 15, they're all divisible by 3. So I factor a 3 out of it. I kind of skip that middle step of, you know, showing what each one broke down into, because I know that 2x times x squared is 2x cubed, 2x times negative 2x is negative 4x squared, and 2x times negative 3 is negative 6x. Also on the right, 3 times x squared is 3x squared, 3 times negative 4x is negative 12x, and 3 times 5 is 15. Now, why did I do that? Because this and this cancel out. Also, this 3 cancels out with this 3. Great. So now I get this new equation where I've just got, you know, what's left inside. I've got this equals this. All right, fantastic. Well, if I subtract x squared from this side and I subtract x squared from this side, then the x squareds disappear. So as long as I subtract the same thing on both sides, I should be good. All right, and then what about if I add 4x over here and I add 4x over here? I'm getting really close to solving this equation now, right? So now I get negative 2x plus 4x is 2x. And then maybe I'll add 3 to both sides. And then lastly, I'll divide both sides by 2. And that gives me 4. The answer to the equation is 4. That is the only place, the only value of x that'll make this equation true. Man, look at that crazy equation. We solved it by using what we call factoring. We factored 2x out of this numerator and 3 out of this numerator, and then we started simplifying. We went from there. All right, that's all I got for you today. If you need to rewatch any parts because I went too fast, do that. You need to ask me any questions, definitely write them in the margins of your notes and compose me those questions. All right, have a good one.